Okay, I'm going to continue with the second part. What I've done is the isotrim, the divide to domain. I have it set to 12. It's probably higher than I need it. I'm probably never going to take it over 20. As a domain, it'll have enough finesse that I'm just going to bring it down to 9. And there we go. We've got some data coming out of here. And where would I take this data afterwards? From these surfaces, because these corners are really tricky to work with, I like to grab my area of each surface as center points, a list of center points. And then the distance I'm going to want is from my original center point distance. And how did I have that tallied? I'm going to go back to the form just in case it shifts, grabbing another area centroid here, and then I'm going to find the distance from this centroid to these centroids, which will give me a value. And that value will then have, and this is where I did a little bit of math, and it's kind of fudgy, but I fought my way through it. I'm grabbing that distance. I'm minusing this distance, which can then be added and subtracted so I don't bug out my script. And then I'm actually going to multiply that distance again by 2. But I want to be able to, actually by 0.2, I want to be able to scale it smaller. So I'm just going to deal with the number 1 slider. I'm going to rein that back to about 2. And I get another number, distance, and that will be the z direction to push up with a little bit of finesse and control those center points. So with those center points, I want to move all of those points with a transformative vector to here. Centroids I want moved in this z direction, and you'll see that's exactly what I get. But what has happened? My z direction, my 0.2, let me see this. Hang on a second. Pulling it down. I think what I've done is I've minus my distance because it's gone negative. I'm going to pull this one out here, put this one up here, and pull this one down in here. And there, that's a wonderful way. That's why I was using that minus from that number, because depending on what this number is, I want this number to be similar, so when I minus it, I kind of get the kind of reverse of that. And it just works out kind of numerically and makes sense for me. Now that I have a bunch of points, I can go back to surface. I can grab my points on surface. I can flatten my points, even though I don't think I even have to. And my U count has to have back to where that U count came from, all the way back to the number 9 that I had set it to. So I'm going to grab here and haul that over here. And there we go. We've got a nice surface. But however, that surface, if I projected up my bottom curve that I originally made, it may actually not be big enough to capture it. So back in the transform, we're going to grab that surface, make it a little larger from its centroid. Now the centroid can be any center, and I think I can use this one as the center, which should work even though it's a little lower. Center, and I want my factor to be, I don't know, 1.22, just to make it oversized. And that's going to have a little bit of finesse on it as well. But that's kind of how the top part is raised. And then you've got a wonderful node called project. And there's many projects, but this is the one you want. Project a curve onto a brep. And the curve we want to move are the edges from that projected model. So I gotta go I gotta go back all the way to my original surface, this surface. And I'm just gonna bring it here for now. That's gonna be the brep that's used. Hang on a second. But I don't want the entire brep. I want to debrep that brep, and I only want to grab the edges, and I should be able to take that to the geometry of that curve, and with any luck, 1 second, direction is set to up, and I've messed it up. I put my brep to my curve reversed, and there you go. 1 sec. Stop streaming.